I'm sure all of you, or most of you, have heard of glow sticks before. I mean, everyone loves them. They're the life of what seems like every party, and they are so much fun to play with. But why do glow sticks glow? When you break a glow stick, certain chemicals get mixed together to form light. This happens because of something called chemiluminescence.
What?
Bioluminescence.
It's chemiluminescence.
Chemiluminescence.
Chemiluminescence?
Chemiluminescence.
What is chemiluminescence?
Chemiluminescence is a term that describes a chemical reaction that produces light. If you break up the word chemiluminescence, you can see that it is made from the terms chemi, or chemistry, and luminescence, or light. So basically, chemiluminescence is the chemistry of light. Chemiluminescence occurs when two or more chemicals react, producing an exothermic reaction. However, instead of expelling energy in the form of heat, this reaction expels energy in the form of light.
When the reaction happens, the molecules become excited and they jump to a higher energy state. They eventually have to release the energy to go back to the ground state energy level. As this energy is released, it can be seen in the form of light.
Now that we know what happens during chemiluminescence, we can take a closer look at what makes a glow stick glow. Glow sticks are composed of an outer shell with an inner glass tube. The outer shell contains a chemical called silyl, or diphenyl oxalate. The inner glass tube contains hydrogen peroxide and fluorescent dye. When you break the glow stick, you can hear a crack. This cracking sound comes from the snapping of the inner glass tube. When you break the glass tube, the hydrogen peroxide and fluorescent dye is let out, and this mixes together with the silyl. When the chemicals mix together, a reaction occurs. Since this reaction is exothermic and chemiluminescent, the energy released from the electrons returning to ground state is in the form of light. The chemiluminescent reaction is an exothermic reaction, giving off energy in the form of light. Heat will give the reaction more energy to proceed in the forward direction. This makes it run faster, giving off more light, but the reaction also proceeds quicker, so that a glow stick in hot water stops sooner than a glow stick in cold water. The glow stick in cold water is dimmer, but it lasts for a longer time. The cold water makes the molecules move slower, which means that they will not come in contact with each other as often or with enough force. The reaction will proceed slower, giving off less light.
Discuss safety rules. When performing this experiment, you should wear a lab coat, gloves, and safety goggles at all times, and always have supervision. Don't forget to clear the area you are working at and make sure there is nothing dangerous nearby. Never taste or inhale the solutions and read all of the chemical labels carefully. Avoid chemical contact with the skin and eyes and wash your hands before and after using any solutions. Thoroughly clean any glassware or other materials used as well. If any chemicals spill, clean it immediately and report the spill to the adult supervising you. And if anything spills on you, rinse immediately with water and report to the adult supervising you. At the end of the experiment, clean up all chemicals and place them into the proper waste receptacles. First, I'm going to add 0.2 grams of luminol to the beaker. Then I'm going to add 4 grams of sodium carbonate, next I'm going to add 24 grams of sodium bicarbonate, .5 grams of ammonium carbonate, and 0.4 grams of copper 2 pentohydride. And then I'm going to add distilled water about halfway into the beaker. Now I'm going to stir the chemicals together. We have moved to a darker area so that you can see the reaction better. Here, I have prepared a solution of 3% hydrogen peroxide and distilled water. When I add the solution to the other mixture, you will see a chemiluminescent light. As I continue to pour, you will see a slight glow. This reaction is now coming to completion. You can see that as the reaction finishes, the solution turns brown.
By doing this experiment, one can see that luminol produces a chemiluminescent reaction when mixed with hydrogen peroxide and a few other chemicals. Chemiluminescence is used a lot, and there are many ways to make things glow.
Chemiluminescence occurs when there is an exothermic reaction that emits light instead of heat.
You can see this happen in our luminol experiment, or you can go out and break some glow sticks yourself.
Ting tang, walla walla bang bang. Ooh ee ooh ah ah. Ting tang, walla walla bang bang. Do 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 do. Ooh ee ooh ah ah. Ting tang, walla walla bang bang. Ooh ee ooh ah ah. Ting tang, walla walla bang bang. Ooh ee ooh ah ah. Ting tang, walla walla bang bang. Ooh ee ooh ah ah. Ting tang, walla walla bang bang. Do 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 do. I told the witch doctor I was in love with you. Do 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 do. I told the witch doctor I was in love with you. Do 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 do. And then the witch doctor he told.
What happened?